All right, we can go ahead and get started. Welcome back. I appreciate the reminder. We got that posted. We're finally moving into sort of the real content of this course with our second main lecture topic that we have here. The name of the topic is reconnaissance and footprinting. Footprinting is kind of a weird word that's not really a verb, but we'll make it work. There's a relation between those two terms. We're going to talk about passive primarily versus the distinction between that and active reconnaissance. And then really it's kind of just a collection of all the various common methods and and tools people use for reconnaissance. That's where we're roughly at in the two online references available for you. And also starting this week is what I call our sort of steady state schedule, meaning we have lab 1 this week. Please attend your lab. We have our second micro quiz this Thursday, and that's going to be the steady state of things. I did want to bring up Canvas beyond to show that lecture slides are properly posted, but also to mention that I think we're settled in terms of the staffing for this class. I wasn't going to go anywhere, but we didn't really have TAs set up yet, and now we do. So we have John and Mason, and they both seem outstanding. Introduce yourself to them this week in lab. Primarily, John is lab sections B and C, and Mason is going to cover A, and they'll both be there in lab section C. They've both taken the course. There's quite a bit of TA experience there as well, and I think it took us a while, but we got lucky, and you have really good TAs. I believe the office hours are also set as well. As I mentioned last week, come join me in office hours. I'm always happy to say hello and get to meet you more one-on-one environment than just this classroom environment. If that's too scary, go meet your TAs in their office hours. Starting next week, I think it's more likely they're going to have their regular office hours. Didn't actually bring up this figure last week. It was in the slides, but we just said we had a lot of syllabus and other things we were covering. This is this picture on the right, sort of our high-level ethical hacking pen testing methodology. We didn't go through it, so I want to briefly do it before I talk about where we actually are as of right now in terms of our course coverage. But it does start at the top there with this concept of reconnaissance as the first step of the hacking methodology. A way to think about it is if you're trying to learn something about an organization without really doing anything that is active, by looking at what's primarily publicly available resources. You're staring into the window from across the street versus trying to break into the house actively. We do tend to differentiate between that kind of passive review of publicly available materials to actively attempting to scan the network of an organization, attempt to enumerate the network posture, the IT organization of an organization. There is a little bit of a subtle distinction between when something becomes passive and then it turns into active. There's also potential sort of legal considerations between sort of passive information gathering and more active information gathering. This first topic, we're going to be primarily relying on the passive side of things. And then once we have an understanding of what is the organization, what is the network architecture, what type of machines are we even interested in, then we can start to look at things like how does one gain access to those machines? How does one discover, explore, use vulnerabilities to exploit and gain access to machines? Or if one already has some sort of access to machines, how does one escalate the privileges they have on those machines? How do you gain more access to those machines? We don't do that much this semester with regards to maintaining access, but we will talk about it. We don't do as much of that with the lab because it's all somewhat synthetic in that sense. And we talk quite a bit about what does it mean to kind of hide one's tracks or hide one's network footprint when they are breaking into a given system. But it really starts, and this topic is our first one here, with this reconnaissance step. We're looking at what is kind of being either intentionally or potentially unintentionally sort of broadcast by an organization. What is being shared publicly by the organization that may provide some additional detail as to what is technically available, what are some of the people working in that organization, what can you really learn about an organization based on what they're willing to kind of tell you publicly if you're only willing to look a little bit further. This is considered passive. I don't know how technical of a distinction ultimately that is. Passive in this context means publicly available information. Now, you're intentionally looking through it and maybe looking at information not with the original intent of those who provided that information, but it's all publicly available information and very much considered to be a legal activity. If somebody posts a site on the web or posts a social media post, you are allowed to look at it. You're allowed to understand and learn things from that information that's publicly posted there. There's also, in this relatively vague term of reconnaissance here, there's also this concept of more active reconnaissance. That is different from scanning and enumerating devices that we'll be talking about next week. Active reconnaissance is more, now you're digging through garbage. Now you're cold calling people, trying to social engineer them for them to give away additional information. The distinction isn't always that clear cut between when something is passive and when something becomes active, and the corresponding legality of your action isn't always that clear. One actually probably needs to have a good legal team in your own pen testing organization to know what things are allowed, what things are not allowed. It has to be something that's allowed contractually. Things like digging through publicly provided garbage is considered legal. Definitely starts to kind of get close to that blurry line of legality and passive versus active. For now, we're primarily going to be talking about today things you can find available on the internet. The other term you will hear, a term that's becoming more and more popular, although I also don't know at the end of the day how critical of a term it is open source intelligence. That is related to passive reconnaissance. That is, what is the information that can be collected or gathered from public/open sources? Not be too dismissive of the term, it's fine. It's also, people who call themselves OS int experts are really just good at Googling, which is fine. I mean, that's an important skill. It's a good survival skill for you as a student. But at the end of the day, that's really a lot of what this is boiling down to. Using search engines and other publicly provided tools to be able to kind of in a more automated and comprehensive way collect a lot of the information that, as you see what we're going to do today, we're a little bit more ad hoc with our approaches. The lab you're working on starting this week is a little bit more of an ad hoc type of approach. The term is also a little bit confusing, or can be conflated for those of us who work in software, because it really doesn't have anything to do with open source software. It can use open source software, but the term isn't really related to the source code for the software that you're using being publicly accessible and open for review and adaptation. It's just sort of open source in the sense of public source intelligence or publicly available intelligence. So the term is cool. Say you're an OS int hacker, that's fine, but that's what that means. Taking available use of the resources that are out there, and there are, it turns out, way more of those types of resources that we ourselves can really attempt to cover. I try to provide lots of links in all of these slides, and when I post them, you can actually access them. For the most part, they're meant to be kind of something that you can also look at offline. When I find something that I think is especially relevant, I'll bring it up. We'll review it here together. For example, those two links that were on that slide number 4 there, one was to this kind of graphical OS int framework, which is fine. It is a way just to kind of visually traverse the different categorization of tools that fall into this OS int umbrella. For the most part, every single thing we will talk about today and on Thursday is going to be found here somewhere. There's a lot of things to go through with that particular website. It's a nice kind of visual view of things. It really depends on what you're looking for. You can't just click around and gain something. You have to have a goal in mind, and we'll talk about, and you'll get some experience in the lab this week, the different goals one may have in mind. May also not be that readable for you when you're sitting there in the classroom, but if you open it up locally, you will be able to find it. The thing with these kind of tools is the landscape just is changing quite frequently, right? On almost a daily basis. uh, just doing things like understanding social networks. Well, what are the relevant social networks? The ways one can access publicly available information that is constantly changing, and so one does need, if you're going to find a resource like this to kind of keep your categorization of these different tools for you, you have to find one that's updated fairly frequently. If something is listed and it's 4 years old, the odds of it actually still working, if it's a technical aspect, is actually quite low. If it's a people website lookup and things like that, it's more likely to still probably be valid. Um, but for example, just clicking around here, social networks, if I want to learn something about an individual now, which could still be relevant for our pursuing an organization, I could click on Steam, Discord, and gaming networks. I'm just trying to pick something that's relatively recent. That gets me Steam OS Int, which sounds pretty cool. I could not vouch for any of those individual links yet. Steam OS Int for Google Sheets. So my assumption is that Steam itself has an API, Steam Web API, and yes, you yourself could write the code, assuming you have some programming background, to take the Steam API, to write a bunch of queries and try to build out the network for this particular user. Who are their friends? What games do they play? What information can we learn based on what's publicly accessible via the Steam API? Here is a tool that does it for you. That's the point of OSINT, these frameworks, these tools that are available that you can then yourself use, have a collection of, and be able to determine for whatever particular task you're currently interested in, what tool is a good tool for the job. If we want to do public records, court criminal records, there's going to be a lot of those sites. Again, I mentioned OSINT is sometimes people who say they have expertise are probably just very good at Googling. There's a lot of just curation of tools going on in this space. So each individual tool is very useful. Now, when you curate them all together, you have these collections of tools that allow you to really have a one-stop shopping for what you need here. Or we'll talk a little bit about username search. There's username-specific search engines, the idea being if I'm aware that there's a particular username in one context of an organization, if it's not just Smith at iastate.edu, it's possible that username is somewhat unique. Is it going to be used in different contexts? That could allow us to discover things like, this is a username that's important. It's a network engineer at this organization. It's a pretty unique looking one. Turns out it gets reused in this, it's being reused in Steam or something. There's been a data breach. We can find the password there. Look for things like shared or reused passwords. None of these individually are going to necessarily solve your problem of getting a full feel for the footprint of an organization, but it's more of an sort of an investigative approach here, right? What can I learn? What can I learn based on just publicly posted information? What can I learn via somewhat careful use of this very long laundry list of tools that are available to me? This is just another resource. For some people, reason there's this kind of meme where if it's a nice list of resources, it's called awesome dash whatever. Here's awesome OS int, and it's quite lengthy and seemingly updated. Whether one needs a graphical representation or just a long list of things, it really depends on how you yourself learn or can consume information. We will go through some of these as we go through the various topics of this reconnaissance topic. No chance of going through even 5% of all the different resources that are available here. It's a good starting point. You can't just blindly do it, and hopefully I'll make that impression on you. You have to have a goal in mind. But with that goal in mind, if you had an idea, boy, wouldn't it be nice if there was a piece of software that took this information and connected to this information? Check those lists first. It probably already exists, but if not, maybe that's a chance for you to make a contribution if such a thing is feasible and has not yet been done. What can we learn? The answer is quite a lot of things via just doing this kind of passive reconnaissance. We'll start with what we can learn in terms of network information, things that you might already know quite a bit about depending on your prior background, depending on what was covered in what depth when you took SciB 2300. You can definitely learn things via, by design, publicly accessible domain information, subdomains, the DNS records. And if that's all review to you today, that's perfectly fine. But we'll go through that. We'll talk about what network information is publicly accessible. System information, to some extent, can also be learned via passive reconnaissance. We'll later talk about how once we start doing things like network scans, to the extent that is feasible, you start to learn a lot more about things like system information. But certainly, because this information has to be publicly accessible, we can learn a lot about what web servers are in use by an organization. If an organization needs to have a publicly accessible web page, then we are able to learn what their web stacks are. That's not something that's really capable of being hidden. And also things like potentially users of an organization. We'll talk about that, and it connects to organizational information, employee information, phone numbers, and emails. That seems to be getting more tightened up over time. There was certainly a time that for a publicly available company, they would have a directory, and you'd be able to find every single employee who worked at that company and with an email address or a phone number. Some organizations still have a little bit of that, but I think the trend is probably in the opposite direction there, where you get a little bit less of that than one used to. What has changed, though, of course, in that same time period is sort of the emergence of social networks, and then sort of the assumption that all of your employees will have a LinkedIn profile of some sort, so you still can learn some things about employees. It's not as simple as having just a pure directory anymore. We may have to do a little bit more work to find that information than perhaps 15, even 5 years ago. Ultimately, and this is why the term footprinting exists, even though it's not really a word, our goal is we're developing a footprint of the target, a better idea of the overall security posture, including, at least to some extent, some understanding of what is the network of this organization. If we even just have a single IP address, which we are also required, they also have to share with us. They cannot have a public footprint at all without sharing IP information. It's our starting point, right? It's not the end goal, but in our methodology, what can we learn about an organization before we even really get started with using maybe the more technically inclined tools to do things like scanning, to look for vulnerabilities, to find exploits for those vulnerabilities. That is our goal. And again, I think what makes it somewhat interesting is it does seem a little soft in the sense that, one doesn't have to be Mr. Robot to be able to do this kind of work, but you can really learn a lot. And so it's an important skill that maybe as we kind of get into the weeds of all of our programming classes and really low-level network administration tasks, we can sometimes forget about how much can be learned really just via clever usage of search engines and the like. We'll start with network information. I'm going to kind of look around the room as we talk about this topic to see, is this all really obvious? It really depends on what flavor of 2300 you took. Sometimes this entire topic gets covered, and sometimes it doesn't get covered at all. So I'll provide my perspective on it, and if it's review for you, that's great. It doesn't hurt to hear something twice or even 3 times. We want to talk first about network information and thinking it from the domain of an organization. If an organization does not have its own domain, then this is a different kind of task we're looking at. But a domain, Microsoft.com, iastate.edu. We need to know as we're getting started, and maybe we're safer just talking about iastate.edu. This is our own organization. We're probably safe in terms of applying these techniques to just Iowa State University. We need to start with answering the question of who actually owns that target domain. There is a sort of global authority. The Internet Assigned Numbers Authority has the overall top-level management of the whole global pool of IP addresses and domain name assignment. And then there's underneath IANA, there's a set of a series of regional Internet registries that manage IP addresses within the respective regions, and then also various companies that work directly with the regional authorities to figure out domain name registration. IP address assigning and kind of geographic information is becoming less and less relevant. And also in the US, the history is a little muddled because of the invention of the internet. What aspects of the IP address space are in North America versus elsewhere. But it's not arbitrary. There are organizations that were set up from the very beginning to handle that management of the IP address space, and then separately to manage domain name registration. When I say the term DNS, just nod. You don't have to raise your hands. Are you aware of what I am talking about? Okay. It's very quiet head nodding. It's fine. We can query those records. Those records have to, by design of the internet, be publicly accessible. I need to be able to publicly request information as to iastate.edu, and I need to be able to get back a response. And that response, if nothing else, has to be able to tell me when you want to go to, let's say, www.iastate.edu, where in the IPv4 address space is that located? The internet does not work without that information being publicly queryable. So this whole idea of, well, my organization is less susceptible to these kind of techniques, maybe so, but the very basic, understanding the most basic of network information is unavoidable if you want to have any public network presence whatsoever. Domain records can be queried using the whois command, which you can do via the shell. Also, there are all sorts of websites that specialize in just providing publicly accessible whois information. You could Google for that. I just brought up a couple here. There are actually a bunch that then wrap that information in trying to provide a little bit more passive reconnaissance on a domain, but that's really tiny. Here, I'm just going to Domain Tools, their own whois thing. Any domain registrar would also be able to provide that service for you. They're trying to sell you a domain, so they provide this information so you know whether or not a domain is publicly accessible or not. So I put in iastate.edu. Maybe zoom in a little bit here. When was iastate.edu's record created? 1987. That's pretty early in the history of publicly accessible websites. The other difference between whois information provided in the year 2026 and what was been provided maybe even 10 years ago is there is a trend to provide less sort of publicly accessible contact information. That's not to say there's no publicly accessible contact information. At the very least, there has to be the records that tell us who registered this domain and what name servers are provided for this name. When I go to www.iastate.edu, someone has to be able to tell me what IP address that actually corresponds to, and to update those records as needed. This is not telling me that much about the registrant at Iowa State University. It's just a sort of generic domain admin or generic tech contact. Anyone here work and know where that actually goes if I email techcontact@iastate.edu? I have no idea. We can find out. 291 Durham Center. Well, we know that's the building that is, I'm kind of turned around, right? That way is Durham Center, and it's on the second floor there. So if you really want to know who's responsible for registering iastate.edu, just go by and say hello. It doesn't tell us that much information. There's all sorts of other kind of whois plus websites. One example is Domain Dossier. Here I've looked up the University of Iowa.edu because presumably their IT infrastructure isn't as good or advanced as Iowa State's. And it lets you provide, thank you, a little bit more information via these checkboxes here. It is still a whois lookup plus other stuff. So this is doing the whois lookup, the network lookup. Now we're learning a little bit more information about uiowa.edu and at least one set of DNS records here. We have an IP address. Again, we need to have an IP address to be able to access that website in the first place. We actually have a name. That could be interesting. I don't know this person. I'm sure they're extremely good at their job, but that's at least a name, and a name that has some authority with regards to the registration of uiowa.edu, and it's something of a unique name, I think. So that's interesting. So I am not going to attempt to hack into any of his accounts, although it's very tempting. I'm not going to do it live in class. If I find out something offline, I'll let you know. But okay, that's at least a distinction between the information that Iowa State provides and what our lesser brethren to the east also do provide in terms of their domain and their whois record. One can also just get a lot of this same exact information just via the command line here. Let's make this a little bit larger. The command is dig. Domain information groper, which is just kind of awkward sounding. Dig, give me domain information, give me just basically all the domain information for iastate.edu. And here we get more than just the DNS records. We get all sorts of mail server, and then just what other text information is provided in the domain registration for iastate.edu. Here's my IP address I can start playing around with if need be. Here's some information. I think you've actually learned something about iowastate.edu if you didn't already know it, and I guess you already do know Iowa State. Let's do uiowa.edu instead. Take a moment. It's a little hard to read, perhaps. What do we know about University of Iowa that we didn't know previously, just based on just running that dig command? IP address, fine. What else? Who runs their mail service? Outlook, yes, as many places. That MX record can be necessary, so to be able to handle mail between domains. It's a good sign that that's using Office 365 Outlook, the same thing we're probably using here as well. Other information is textual records to help with various other sort of cloud-based services. And they, at least I haven't really been able to determine what one can really detect from that beyond the fact that there's some registration of information here for OpenAI, for Google Sites, for Apple domains. I don't think any of those additional information. I haven't been able to find like there's some leakage of information via those kind of arbitrary keys provided at the end there. But it gives you a feel for a little bit more about what's happening with an organization. And that reminds me, I do want to talk a little bit about, and I mentioned it last week briefly, what you will be doing in the lab, what your sort of work product in the lab is going to look like. And for Lab 1 at least, it's going to be a lot of this, right? You're going to be doing a lot of this, of run this tool, pick this domain, what information can you learn? So we're doing the mediocre live version of that in class this week. What's really critical for you and what your work product is for those labs is documenting what you've done. That is for me so that I can provide you a grade. That is also for you so that you can have some good documentation of the work that you've done. Unless you just have an ironclad memory where every command you've ever run and any result you've ever gotten is something you just instantly commit to memory, and I don't believe you if you say that, you have to keep track of what you've been doing. What can be a little bit tricky with this kind of work is, copy paste sometimes has kind of a limited usefulness. Depends on the resource you're using. If it's a command line output, probably you're okay that you just copy paste the text into your journal into a file somewhere and you're okay. If it's a website that you're using to grab this more visual data, then screenshotting is where you're going to be. So your work product for Lab 1 and going forward is just a series of screenshots, write-ups, documentation of the steps that you took and the results that you got. You can do this the easy way or you could do this the hard way. A part of Lab 1 documents talking about the various screenshotting tools that are available. It doesn't really matter what you use as long as it works for you and as long as you're effective with doing that. Your actual lab report is a Word document that's provided for you that you just update that template. But how you're keeping track of your screenshots and data is up to you as long as you do it. As long as you have that reasonably well organized. There's 12 weeks of lab. There's 12 labs in this class. Have 12 different sub-organizations of whatever note-taking software you decide to go with. Have a way that you can effectively take screenshots and access those screenshots. Every computer is different. Every operating system, every piece of software. Command Shift 5. Okay. Woo. on Mac OS. And let's say this information, I would probably want to capture the command as well. Let us assume that this information was really important to be captured for me in graphical form. I use whatever keyboard command. I mean, if you want to find the utility and have it open, that's fine as well. Probably try to remember what quick keys, combination works for your particular setup, because you're going to be doing it a lot. So save yourself the trouble of opening up a snapshot app every single time. Learn how to use your screen capture app. Have a way in which you know where your things are being saved. This is probably saved in the desktop. It's hard to say. It saved it somewhere. Do we have a PNG file on the desktop? We have a couple, one from the other day and one from today. There's then all sorts of other software if you've taken a screenshot and there's some actual text that you want to extract. The tools have gotten significantly better between now and even like a year and a half ago of doing optical character recognition, taking an image and extracting the text from them. There's so many. I don't want, the one that I have installed that I use all the time is Tesseract. You can see I have run it before. Smart autocomplete gets me again. Tesseract, take the screenshot, output into text, and there should be an output.text there. And hard to say for this because it was already text data that I took a screenshot of and then converted back to text. But if it wasn't the case, if it was a combination of visual data and text data, that's a pretty useful tool. I've taken my screenshot. I have the screenshot saved somewhere, hopefully not just as an arbitrary thing on your desktop, in a folder at the very least. And then I can actually grab the text from that in an automatic way as well. Your whole flow is probably not going to be automatable for this class. There's just too many kind of ad hoc steps for what we are doing in the lab for this class. But over time, I think you'll develop your own flow. And we talked about that last week a little bit as well. The more you can automate those steps, just the more effective you will be, the more time effective and efficient you will be in terms of doing this kind of work. Any questions about what we just went through just there? We covered a lot just all of a sudden. DNS entries, whois or dig command to grab more of that information. We'll talk a little bit more about that in just a second here. And then I just showed the command line version of that, and then try and be a little clever and do optical character recognition. Extract the text from a screenshot of the commands that you are running. Can be a very useful thing for all sorts of context, but for doing this kind of reconnaissance, it can be a very useful time saver for you. Final note, just to reiterate one more time, that is your work product for these labs. So I try to make it pretty straightforward or pretty unambiguous what I ask of you every single step along the way, but that's what you were doing. So don't attempt to do the lab and then attempt to go back and document everything you did for the lab. You'll be a little bit slower. Document your steps as you are doing those steps, and you'll just find it a relatively pain-free experience. Domain name system is organized as a hierarchy or as a tree with our root domain and then the subdomains within it. So we have our .com, and underneath that we have google.com, and then underneath that we have the various subdomains within google.com. You can grab that additional information by querying those servers directly. We saw one brief example of that with the any command. So you get your IP addresses, you get your name servers, and then we saw that you get your mail servers as well. There are all sorts of really good OS insights for doing this kind of work. We just did domain dossier, which was fine. Another one is DNS dumpster, which is attempting to do that. Reload page and try again. Let's keep picking on uiowa.edu. Now, this is a website that is attempting to automate a lot of the passive reconnaissance steps. So it is more than just DNS information, but it's not a bad place to start. And by the way, let me add that, okay, there was those long lists. There's a couple of those graphical websites of the different OS and tools. If any of you find something that you're finding useful or you just stumble across something that isn't on the list, hasn't been covered, please feel free to share in our class Discord. I'm always happy to learn about more things. There's a lot of things out there, and people have their favorite tools that they learn how to use over time. This is DNS dumpster here. An attempt to provide a little bit of a network footprint here. So to the extent, I can't really vouch for the accuracy of this particular website for finding that kind of information. It claims Nginx as well as Microsoft IIS as the main web servers being used here. Here are all the A records that it's here. It's displaying 50 out of the 30,855 A records. That are all the various subdomains of uiowa.edu. Universities tend to have a lot of subdomains. Every college, every department, every grad student, everyone has their own separate subdomain. At least historically, that was the case. So I'm not that surprised that there are so many of those records. But to me, what is then interesting is I am sure that person whose name we just discovered is extremely good at managing the domain at www.uiowa.edu, and they have a very good team for that. Is that equally the case for every single one of those 30,000 records that we have here? And is it also then potentially the case that a vulnerability discovered in one can then be piggybacked upon to become a vulnerability that spreads to others? So maybe this is a little bit unique to uiowa.edu, that academic institutions tend to have all sorts of subdomains. Very early to the internet, very kind of everybody gets a slice of the domain. But this is definitely the case that there's a lot going on here, and all sorts of different servers, a whole bunch of different IP addresses, and a lot of things one can learn about from this particular website, the different technology stacks being used, where the entry point is for those technology stacks. There's almost too much of a wealth of information. You have to kind of focus in a little bit and figure out where potentially one would want to start. Again, I'm sure the main primary entry points are very well managed, protected, reviewed. Is that going to be the same case for every single one of these websites here? Or is one of them actually running a server from 2003? It's very possible. That's just my opinion. I haven't actually broken into iowa.edu. And I will not do so live in class, as I've already said here. Another great resource on DNS and the issues related to copying records, it's called zonetransfer.me or zonetransfer.me. And it's really talking about this DNS zone transfer. It's the mechanism by which we use, it's a query type AXFR, and that you can use that same dig command. And it's a method, it's a type of DNS transaction where we're actually requesting, can we replicate this DNS entry elsewhere? And that is an example, this website, which I won't go fully through here, although I can run that command to show you locally what that output looks like, is another way to show that what information can in fact be provided via those DNS entries here. And I believe this example, he allows people to do the zone transfer and add your own information to the DNS entry. I think this kind of understanding of the security issues related to DNS has really intensified even in recent, last couple of years here. It's less likely you're going to find a professionally managed organization that would have such an open DNS record available for copy. But it depends. I mean, it could be a mom and pop, organization that you're interested in, not Microsoft.com or Google.com, that they have all sorts of site reliability engineers and IT security people working for them. That's a good website to take a look at offline. Look at zonetransfer.me, that last link on that slide here, to see all the various things that can be put, hi to Josh and all his class, that one can put in your DNS entries there. So via that same network search, which the domain dossier provided, that the domain dumpster also provided. You could also directly search via the ARIN website to see what is the primary IP address associated with, if that's an American website, with the registered domain here. And then you can definitely trace that path. That can be a very interesting thing to do. How many of you are familiar with the traceroute utility? Did you use that in 2300? Just a couple of you, or maybe you used it elsewhere. Traceroute's pretty important. We will do that in this class, although the routes are all, starting in Lab 2 are all our own routes, so there's only so much one can do with that. It's a very common thing then to say, for the IP address we're interested in, how does one get from where I am to that particular IP address, and to understand what are the various hops along the way. And it could be the fact that the weakness that we want to consider exploiting further is not actually at the final destination. It could be at one of those steps along the way. So the traceroute command allows us to at least partially get a feel for what are the other IP addresses one has to traverse from the current network, from your current IP address, depending on how you're connecting, to that destination. I don't know if trace routing to iastate.edu would be that interesting. We can do it since we're here. We're currently on campus, but the web server itself could be located elsewhere because it's probably cloud hosted and not on-premise hosted. So we provide that traceroute command in our end destination here. You could also just provide it via IP address. So you can, instead of looking for the main website, you can look for any IP address on campus. Let's actually do that real quick here. Most of this is just our own internal infrastructure here. So let's do a trace route to one of those IP addresses that we saw. It shouldn't have to go too far from this machine to a Wi-Fi access point to, should just be a series of routers along the way. Traceroute's kind of fun. Are we familiar with the ping command and ICMP packets? My admittedly not leading expert understanding of how traceroute ultimately works is just sending a series of those ping packets. As part of those ICMP, those ping packets, you can specify, I'd like to ping this IP address space, but I'd like to stop trying after you've gone through 3 or 4 or n number of hops. And that's called like time to live. Send this packet out, but if it takes more than 5 hops, give up. And let me know where you got, but give up and return what you have at that point. And so it's kind of almost a childlike sort of algorithm, but quite effective, that is saying, I want to go to that IP address, but please just take 1 hop. Well, unless you're directly connected, it will take more than 1 hop. That's the first line, that first entry there. Attempt to go to that IP address, but give up after 1 hop. All right, there's the information that returned back. Now attempt to go to that same IP address and return after 2 hops. Now try to go to the same IP, et cetera, et cetera. Now, I think in practice, certainly as you get to inside the periphery of an organization, I think it's less likely that the traceroute is going to provide all that much meaningful information, because the routers and switches and other network infrastructure can be configured to not return that information. It assumes that everybody is going to allow it, but there's all sorts of reasons, including for the security posture of your organization, for it to not return that information. The last thing we can do, that's our traceroute command, is that there does exist tools and websites, fewer sort of publicly accessible ones, that do attempt to provide sort of a graphical view of where an organization is found. So this is a visual traceroute tool. The issue with a web-based tool for something like this is, well, I'm connecting to a website and then running the command from that website. So the traceroute, well, do we see anything that looks a little suspicious with where that traceroute is going in terms of the visual look? Sure. Which, there's nothing wrong with going to Finland, but I don't know how well I can actually zoom in here. I'll try. It's starting in the United Kingdom. That is not my IP address. That is the IP address of it doesn't have to necessarily be the web server this, but wherever this is launching the command from to be able to do that traceroute is quite possibly just the web server that this website is located on. So it's not exactly a point-to-point location, but it does give you some sort of feel for uiowa.edu. I think there's more information, but the rest of it gets kind of hidden because it's not every router along the way is returning it. Any idea why Iowa would be based in the Washington, D.C. area? I have a feeling iState.edu as well. Any idea? Okay, you got it. I'll wait for someone else. You have an idea. I don't know if you have it or not. Why? You might find a lot of websites from the Midwest are located in the D.C. metro area.
I was just going to say, because it's a public institution, so it has to be registered with the government.
That would be nice. I don't think it's a valid guess. It is registered with the government. Here we're actually trying to trace the route from London, for whatever reason, to the web server itself. Who is actually hosting the website www.uiowa.edu? And I think you'll find, although having said that, let's actually try it. Middle of the ocean. That's unlikely. I think it's in the middle of it's still processing here. I think you're going to find a lot of websites that one goes to are going to be based out of there. There's a very well-known cloud server, Amazon East. Their kind of major Eastern hub is based out of that area. And it is, for whatever reason, perhaps because it's the oldest, the original of their cloud infrastructure providers, so kind of the default for a lot of organizations. So it is kind of interesting in a sense that I go to iastate.edu. There's no way it's in the middle of the river here. That's not the ocean, it's the River Thames. Let's zoom out. It didn't seem to work this second time here. I've broken it, which is fine because it's got a lot of links that it wasn't able to figure out along the way. So it got stuck well before it crossed the pond here when I did that one. It is kind of interesting though that we go to uiowa.edu and you probably think, well, it's going to be in Iowa City or Cedar Rapids or Des Moines or Chicago or something like that, and it goes all the way out there. I think if we had gone back to the domain dossier website, I think we would have seen some information that would have given us a hint that that was the case. We'd really just want to look at the main entry for uiowa.edu and not for all of them. So I don't think we actually want that whole dumpster fire of information. And when we look at for our who is for the main network range that they have here, so University of Iowa has a lot of /12s. They have a lot of IP address range, and their main hoster here, main provider, that's Amazon. So they're like many things in the world hosted on Amazon Cloud Services. So that's why when we did the visual trace route, we found ourselves on the East Coast and not in central or eastern Iowa. Let's leave things here for today. I think that's sufficient. We have more that I'd like us to cover, but for now, I think that's enough that we can pick this up right here on Thursday. Please come to your lab this week. Please come back on Thursday for your micro quiz. Otherwise, enjoy. Look forward to seeing you then.